Hello, AP Chemers. We're starting Chapter 13 today. Chapter 13 is relatively short because a lot of the colligative properties and other things in this chapter are taken out of the AP exam, like molality and percent by mass and all that stuff. So it's relatively short. There's only a few learning objectives here that you are responsible for. So let's start Chapter 13, which talks about solutions, by first defining the different parts of a solution. So to make a solution, you need a solute and a solvent. The solute is the substance that's being dissolved. And of course, the solvent is the substance that's doing the dissolving. And so a solution is a homogeneous mixture made of the solvent and the solute, of course. And so when we add a solute to a solvent, it changes some of the physical properties of that solvent. Let's look at concentrations next. So when we make a solution, it is really important to know its concentration. Like if I have an NaCl solution, I could put in a cup of water, for example, I could put like a couple of grams of salt, or I could put, 100 grams of salt. So we really care about how much solute to solvent there is. There are many, many ways to express concentration. The one that is favored by chemists is molarity, and molarity gets the symbol capital M, and it is moles of solute per liters of solution. There's also mole fraction. So mole fraction is X, and it is moles of solute over total moles. Molality, lowercase m, is moles of solute over kilograms of solvent. And molality is not something that you need to know for the AP exam. It is something we studied last year, and it's definitely something that you need to know for college chemistry. The only time we use molality is for colligative properties, if you remember, like boiling point elevation, freezing point depression, stuff like that. And the colligative properties are out of the AP exam, so you do not need to worry about molality for the AP exam. Next is mass or weight percent, and so this is grams of solute, or mass of solute over the total mass, and then times 100%. Let's look at the units. So the units for this one would be capital M, which we pronounce as molar, or moles per liter. No units for mole fraction because it is moles over moles. For molality, the units are little m, which we pronounce as molal, or moles per kilogram. And for mass or percent, it is just percent. It's not really a unit because it's grams over grams and then times percent. So again, no calculations of molality on the AP exam. Let's try a problem here. It says if you dissolve 10 grams of sugar, C12H22O11, so it's a sucrose stable sugar, in 250 grams of water, find the molarity and the mole fraction. And they give us the density of that water. Let's start with molarity. So molarity is moles of solute over liters of solution. So let's see if we have either. For moles of solute, we are given that we have 10 grams of sugar. So let's find the moles of that. I'm going to do it on the side. 10.0 grams FC12H22O11. 1 mole of sugar. I believe the molar mass is 342. Yeah. And that gives you 0.0292 moles of sugar. So we're going to plug that in here, 0.0292 moles, divided by the liters of solution. So we can get the liters of solution by taking the mass of the solution, so 250.0 grams plus 10.0 grams. That's going to give us a total of 260 grams of solution. They tell us that the density of the solution is 0.995 grams per centimeter cubed is milliliters. So I'm just going to do that. And for my um, 261.3, and this is milliliters, which is 0.2613 liters. So right here I'm going to put 0.2613 liters, and my molarity ends up being 0.112, and again this is molar or moles per liter. Let's do the mole fraction next. So for my mole fraction, X, can't write this, is equal to moles of solute over total moles. For my moles of solute, I have 0.0292 moles of sugar divided by my moles of water. So let's do the moles of water on the side here. 250 grams of water, change that to moles. 1 mole is 18 grams. This gives you 13.89 moles of water. So we're going to do total, so 13.89 plus the 0.029, and that ends up being 0.020021, and no units for the mole fraction here. Okay, so how do you make a solution? This obviously the AP exam does not have a lot practical, but this has been a pretty popular question on the AP exam. How do you make a solution of a certain molarity? So to make a solution of a certain molarity, you want to use a volumetric flask. So volumetric flasks look like this. Let me grab a couple. They come in all kinds of different sizes, but you basically have a really big bulb at the bottom and a narrow neck. And like I said, they come in different sizes. So this is 1,000 milliliters or a liter. This is 250 milliliters, so 1/4 of a liter. This one is 100 mils. So they come in really small ones, like 5 mil ones, and then they come in really big ones, like 4-liter ones. So you pick the one that is the correct volume for your solution. And let's say you are going to make 250 milliliters. So you pick the one that says 250 milliliters. There's only one line here. So these are really good for making a solution that's this volume. They're really bad if you're measuring any other volume. So it's important to pick the one that is the correct size for you. You take your substance that you're going to try to dissolve, you mass it, so we're going to pretend that I massed it here, and you are going to add it to your flask. So if you bend your weigh boat like this, then it's pretty easy to pour it in. And then you're going to add water, and you want to add a lot of water so that it's about half way filled. And the reason you don't want to fill it all the way at the beginning is because if you fill it all the way to the top, then it's going to be hard to get that salt to dissolve. So what you want to do is fill it but only halfway that we have room so that you can swirl it around and get it to dissolve. Once it's dissolved, then you want to add more water. When you get to the neck, you want to add it really, really slow, maybe with a pipette or a squirt bottle or something like that. You want to be eye level with it, and you want to add it to the bottom of the meniscus. Then you stopper it and invert it a few times. That way you get it all mixed in. So that's basically how you would make a solution in the lab. In terms of the AP exam, this is what you want to say. So you mass the appropriate amount of the solute, add it to the correct size volumetric flask. You probably have to mention what size in a specific problem. You fill it halfway with distilled water and swirl until the solute dissolves. Then you add more water until you reach the mark. You stopper and invert a few times so that it's all mixed. Okay, the next topic is dilution. So dilution is the process of adding water to a concentrated solution to make it less concentrated. And the equation for dilution is M1V1 equals M2V2. Now let's talk about what this means. So if I have this solution here, this solution has a certain molarity, like concentration. It has a certain volume. It has a certain color. It has a certain amount of solute that I have in here. Let's say I want to dilute it, so I'm going to add water to it. So I'm going to go ahead and add water to it. And now that is a diluted solution. So we're going to call it the diluted solution 2 and the concentrated solution that we had initially, solution 1. What is different? Well, the color is different, the volume is different, the concentration is different, but what is the same? They both have the same amount of solute. The moles of solute that I started with are the same in the concentrated solution as they are now in the dilute solution, right? Because all I did was add water. So my moles of solute remain the same. If you look at this equation, if you take molarity times volume, that ends up being the moles, right? Let's look through our units here. So if I take the molarity of solution 1, that means the moles of solute in solution 1 over the volume of solution 1, that's the molarity, times the volume of solution 1, which is in liters. Look at this, that cancels, you end up with the moles. Same thing here, if I take molarity of solution 2, which means moles of solute over liters, multiply by the volume of solution 2, my liters cancel and I end up with moles. It is true that the moles of solute in my first solution are equal to the moles of solute in my second solution, and so I can set M1V1 is equal to M2V2. So this is the dilution equation. That's the equation that you would want to use when you are diluting a solution. Let's practice a mathematical problem. It says, what volume of 16 molar sulfuric acid must be used to prepare 1.5 liters of 0.1 molar sulfuric acid solution? So I do problems like this all the time when I'm prepping labs for you. A lot of times when we buy our acids, they are really concentrated. That way we don't have to pay for a lot of water for shipping. And so we have to dilute it, but we don't want to dilute the whole, 4-gallon container or something like that. We just want to dilute enough for our labs. So let's say I need 1.5 liters of 10th molar sulfuric acid for a lab. And the concentrated stuff I have is 16 molar. So what do? I do an M1V1 problem. So I do M1V1 equals M2V2. Basically, I'm trying to figure out how much of this I use in order to make 1.5 liters of 10th molar. So this is one solution right here, and this is my other solution. So I'm going to say 16 molar times V1, or X, is equal to 10th molar times 1.5 liters. And I solve for V1. That's how much of my concentrated stuff I need to use. So when you do that, see if I have this in my notes. I'm going to go ahead and calculate it real quick. So 10th molar times 1.5 divided by 16 molar, I get 0.009375. So V1 is equal to 0.0094 with sig figs. This is liters, so you can convert it to milliliters if you want. It's 9.4 milliliters, either way. So how would I do this if I were in the lab? And again, that's a popular question on the AP exam. So sometimes they'll just ask you a question like this, what is the volume? And sometimes they'll ask you like, write the procedure for how you would do it. So you would figure out how much of your stock solution, your concentrated solution you need. So we need 9.4 milliliters. And again, we're going to use a volumetric flask. So we're going to pretend that this is 1.5 liters. And so you measure out 9.4 milliliters of the 16 molar. You add it to your volumetric flask, and then you add water until the mark, and then invert it so that it all mix. Why don't you need to add water halfway and swirl? Because it's already dissolved. It's already a solution, so you don't need to do that. So let's read the directions together for diluting. So you measure the appropriate volume of the concentrated solution, add it to the volumetric flask, then you fill the flask with water until the mark, you stop it and invert several times to mix. Now here's a little note that's relevant to this problem, because sulfuric acid is a pretty strong acid and 16 molar is really concentrated. So it's telling you here, when you are diluting a strong acid, and this only applies if it's a strong acid, you always add the acid to the water, never the other way around. Otherwise it's going to splash. So when we say you're going to put your concentrated stuff and add water, that would splash. So you have to be careful when you are diluting a really strong acid. Add some water first, just a little bit of water, then add your acid, and then add more water until the mark. So that's what this is saying here. So it says when you're diluting a strong acid, place some water in the volumetric flask before adding the acid slowly, then continue filling with water until the mark. This avoids splashing because mixing a strong acid with water is exothermic and it can splash. So again, only for strong acids that you need to just keep a note of that. When you are, sorry about the grammar here, when you measure the volume of a solution in order to dispense it, so when we're trying to measure the 9.4 milliliters here, you want to get the most accurate or precise glassware for that. And so the best one would be a burette. That would be the most precise, followed by a calibrated pipette, like those glass graduated pipettes, followed by a graduated cylinder. We obviously never ever measure in a beaker. So if you're given a choice between all the glassware, you probably want to use either a burette or a calibrated pipette. You can also call it a graduated pipette. Those both work. You don't want to use a graduated cylinder unless that's the only glassware that you have.